Please welcome the Senior Site Reliability Engineer at Mailchimp, Bob Strecansky.
Hello, everyone. I'm Bob. I'm a Senior Site Reliability Engineer at Mailchimp. You can find me on Twitter and GitHub at Bob Strecansky. Today, we're going to talk about some development best practices with Akamai in mind. All of these slides will be available after my talk. I have a URL at the end, so don't feel like you have to take any pictures today. So let me first explain a little bit about myself. I graduated in 2010 from Clemson with a computer engineering degree. Go Tigers. And then I started in the consulting world. And then I worked for this little company that you might have heard of, Akamai. Today, I'm working for a company called Mailchimp, and we help to enable small and medium-sized businesses with their marketing efforts. So in 2010, our CEO, Ben Chestnut, made this blog post, and I found it on web.archive.org recently. It was talking about how to speed up Mailchimp. At this time, Mailchimp was really, really customer-focused, and we were more worried about building products and services for our customers than worried about the actual performance of the website. So the title of my talk today, When 7 Seconds Isn't Fast Enough, is a reference to this blog post, because Ben talks about how if a page takes longer than 7 seconds to load, it's too long. Obviously, it's a little different now, because we have all sorts of really cool web technologies to help us make this effort a little bit better. But the same core tenet still stands. If your site is slow, your customers will be unhappy, they may leave, and they may be disgruntled. So we're going to talk about a couple different things today to help with Akamai performance from a developer mindset. We're going to talk about modern Akamai configuration practices. We're going to talk about how to balance cacheability with a developer focus. And we're going to talk about chatops using Akamai APIs. So we're going to talk about modern Akamai configuration best practices first. I hope you're all ears. Our Mailchimp artists are pretty great, aren't they? So who here has seen an Akamai configuration that looks like this? I have. So most of your Akamai configurations have been around for a very long time. Akamai's Property Manager is a powerful tool that helps you build Akamai configurations in real time. It's been around for a couple years now, and configuration management is going the way of the dodo bird. As a matter of fact, it actually was deprecated on June 1st. I think that's worth giving the Akamai people a round of applause for. I really just liked working with that when I was at Akamai, so anybody who's had a chance to work with Configuration Manager should be very happy for Property Manager. So Akamai configurations, if not managed with good expectations, become complex very, very quickly. You have business logic that becomes convoluted. You have individual Band-Aids that you have to apply at release time or when you're facing a problem that become permanent. And then your fast fixes will gather over time. So all of these things together really makes for a spaghetti code version of your Akamai configuration like we saw the GIF of earlier. So what should we do to combat this? We should make a cookie cutter template. This was a cool fringe benefit of doing this talk. I learned about how a cookie cutter is made. So there's a couple things that you can do to have a reusable, configurable template for Akamai configurations. You can create a reusable template, and you can use some of these other tools that they have available in order to make your configuration very modular. So one of the things that we can do once we have this modular configuration with just baseline parameters set is use the Akamai CLI. So Akamai has a bunch of really new, wonderful CLI tools that can be available for you to use. You can check your DNS configurations via FastDNS. You can update and look at your SSL certificates using CPS. There's actually even a way to purge your assets via this CLI with Akamai API. There's a lot of talks this week at the conference about the CLI. It's just important to have visibility on it. There's even a new CLI called Property Manager that lets you update properties in real time. So this is really wonderful. And if you have this cookie cutter template where you don't do any special fun configurations for each Akamai configuration, you can use the CLI to deploy new things. This is really important as we get to the advent of microservices and individual services for each thing. It also helps with rapid innovation. So if you want to set up a new service and you're not sure of the scale that you're going to see with the new service, if you have a baseline cookie cutter Akamai template, just throw it behind that. And you can keep developer and operational velocity while allowing your site to be protected via all of the things that Akamai has to offer. So the next thing we're going to talk about is reducing developer toil. So to all the people in this room that deal with Akamai on a semi-consistent basis, we understand how it works. But a lot of developers really aren't concerned with it. It's just a black box to them. They say, my information goes in, and then an end user makes a request for a website or a web page or a web app or whatever, and they get the result, either cached or not cached. The developers are so focused on keeping business momentum that they're not concerned about the cacheability and performance and all these things that Akamai offers to us. So a couple of fun practices that you should follow in order to be able to keep developer momentum is give them a place to test this out. Use the Akamai sandbox or create a separate Akamai configuration that's just for your staging environment. This staging environment can be on-prem, in the cloud, it doesn't really matter, as long as it is near like what you have in production so that your developers can feel confident in the changes that they're making. This test instance is very important to Mailchimp, and it probably should be important to you at your company. Who's seen a graph like this? 0 errors in production? I've never seen this either. I actually took this from a decommissioned host. It's really, this is something that a lot of people strive for, and it's not really tenable. Your servers will act funny. Your end users will do things that you would never expect in a million years. You'll have network outages. You'll have bandwidth problems. You'll have co-location facility problems. You'll have cloud outages. The possibilities are endless. So you have to recognize systems will fail. And you need to make sure that you have something to do, something that you can do in the places where these systems do fail. So if you do all of these things that I mentioned, we'll be able to continue with our velocity. A couple other things that you may want to consider for your particular company is a SAN wildcard certificate from Akamai. This is something that's not often touted, but it's really helpful. A SAN wildcard certificate lets you have subject alternate names and wildcards in the same SSL certificate. A lot of the times you'll have one SAN certificate and one wildcard certificate or multiple wildcard certificates. And this gets untenable quickly. You need to add a new product or a new service. You don't want to have to go back in and wait for CPS to update and then validate that the SSL certificate is working as expected, so on and so forth. If you just buy a SAN wildcard certificate, you could toss a bunch of these in advance and not have to worry about it. This is really fun. As I mentioned, the Akamai CLI tool helps you make changes to all of these configurations as you continue to grow your specific services or your business goals. And make sure you have separate content provider or CP codes available for use. They're free. You can ask your account representative to create a bunch for you in advance. And then you can use them in specific instances, like say you set up a new microservice, or say you have something that you want to be able to monitor a little heavily with all of the monitoring tools that Akamai has to offer. Having these separate CP codes on the ready can be really helpful for maintaining momentum with building a new service. And last but not least, make sure that you're using Cloud Monitor, or now it's called Data Stream, to send your data somewhere. Akamai can stream these logs in real time to you, and having this knowledge can offer a lot of real power. It can help you make the business decisions that both your developers and your operators can agree on very quickly, rather than having to sed, grep, awk logs, or go through Elasticsearch or Splunk, or however you want to do that. If you do all these things, you can keep your momentum going up, sort of like my favorite emoji here. The next thing we're going to talk about is balancing cacheability with a developer focus. So knowing how Akamai's caching system works will help us to use the cacheability rules to our advantage. This is really important, and it's something that's not often talked about. So here's an example cache key from Akamai. We're going to go through this step by step so that everybody in the audience understands exactly how these cache keys are formed. So the first thing in the cache key is a /s, hopefully. This means that you're serving secure content. In 2019, serving HTTPS traffic is very, very important. If you want to give your customers a very secure session and you want them to have their data encrypted, then this is a really important thing to add. So if you're serving HTTPS traffic, you'll see a /s at the start of the X cache key. So the L, this one's sort of a fun piece of trivia. If you make a request through a C-named URL, you'll see an L here. It receives a corresponding but different type code from the legacy free flow URL, which is a decade ago in Akamai land. This should be really unimportant to everybody in the room today because free flow isn't really used as much as it used to be. But it's just really good for historical context, and so that you can understand the entire X cache key. The next thing is the serial number. The serial number helps you to map which SSL certificate that you're using with your CNAME. You'll note that when you dig your hostname, the CNAME that your hostname is tied to is the same as the serial number. This is really good to know. The next thing is the CP code, the content provider code. And this is very important. It helps with billing, logging, monitoring, alerting, so on and so forth. Being able to know what CP code you're using helps you to determine what your best step is. Oftentimes at Mailchimp, if we have a particular problem area that we want to investigate in more, we'll just add a very simple criterion behavior match in Ion that says, if path is foobar baz, apply the CP code. And then you can look in Akamai's reporting mechanisms, and you can actually you can take a look and see what's going on with foobar baz just by looking at that particular CP code. The possibilities here are endless. I would encourage you to investigate them. The next thing that's in the cache key is the time to live. So in this particular instance with example.com, we have a 4-hour time to live. One very, very important thing to note, if there's one thing you take away from this talk over all else, this 4 hours is not the time left in the cache key. It is the total amount of time in the cache key. I've seen people burned by this before. They think that they have 4 hours left in the cache, but really they only have 2 hours left in the cache because this shows the full time to live, not the current time to live. The next thing is the request host name. For a very long time, we used origin dash the property name as a common convention for this value. However, security researchers in like the early 2000s, mid 2010s decided that this was not a good pattern because then you could just go to the origin record of any host by going to origin dash. So then we started obfuscating this. We put some funky string before this and create some fun DNS entries in order to be able to obfuscate this a little bit. But what we have to remember is all of our R and IP address space is published. So anybody can go in and look at that and just scan your IP address space. So this isn't as important as we once thought it was. I still like to obfuscate it because anything we can do to make sure that people can't touch our origin is important. But it's just important to know that this is what that is. And last but not least, we have the URI path. So this, by default, takes the path that is associated with the request and stores it. You can also add a lot of other really neat things to the URI path X cache key. You can add query strings. You can add request headers. You can add request cookies. All these things can be added to the cache key to return different results. So if I have /path on one request, and I have /path query string equals foobar, those two things can be stored as separate values. But you have to make an Akamai rule for it. This is important to remember, and it's a constant source of frustration for developers. So the more we can evangelize these rule sets in Ion, the better off we're going to be. So next, we're going to talk about reducing operational toil for developers with versioned assets. Has anyone here heard of Webpack before? Cool. Webpack is really neat. It's an open source JavaScript module bundler. So this allows you to take your JavaScript, bundle it all up, and serve it out. What's little known about Webpack is you can bundle CSS, you can bundle JavaScript, you can bundle images, you can even bundle HTML and give specific versioned assets for each of these things. So what we have to remember is what we talked about in the last section with going through the entire CP code. If we have a specific path that's versioned, we can cache these assets for a long time. We can cache them for a year in the browser and at Akamai so that we can increase our cacheability while maintaining a developer momentum. So when developers publish a new version of the asset and it's referenced differently, the old object just sort of floats around in cache until the LRU goes away. And then we serve the new object from cache when we update the reference to it. This is really cool. One thing that's very important to remember here is if you do full page caching, if you update the underlying assets behind full page caching, they won't update in the HTML that is fully page cached. So this is, if you decide that you want to do this, you need to make that association in your build configuration. So here's an example of a Webpack output. As you can see, there are a lot of different URI assets here. And we can see that the hash string that goes before the .js or the .css changes. So this is how, like I mentioned with the path, we can change a new asset and serve it up while we're still serving the old asset concurrently with a cache. This is really nice. So Varnish is the last thing that I'm going to talk about in this section. Who here is familiar with Varnish? Varnish is really neat. It's a software tool that allows you to set up your own cache internally. So a lot of the time, it's used as a caching layer between your infrastructure and the external infrastructure. In this case, it's Akamai. So why would I do this? Why would I want to add another caching layer that I have to futz with between me and Akamai? Shouldn't I just cache everything at Akamai? Seems like a valid question. Adding Varnish is really nice because it allows you to keep your caching configurations as code. You can use the edge control header in your infrastructure. If you send that up to Akamai, Akamai will treat the edge control header as the caching time to live. So it's really nice. You can update one of your assets, change the Varnish time to live, and then with a header, Akamai will cache it the length that you expect. So you can have two places to do caching mechanisms. Configuration as code is becoming more and more popular in a DevOps world these days. And being able to have this stored someplace in a GitHub repository or some other version control asset is really helpful for your developers to have visibility into the caching rules you want. Not all of your developers may or may not have access to the Akamai portal. They may or may not have experience looking at the caching rules for a particular product or service. But being able to see that really helps to increase visibility. The last thing we're going to talk about today is chatops using Akamai's APIs for developers. I really think that this is a slam dunk. Seriously, our Mailchimp artists are really great. I really like them. So we're going to talk about a couple different topics here. We're going to talk about blocking bad IP addresses, enabling our customer support teams, and arming developers with information. So who here uses Slack at work? Slack has been very helpful. A lot of DevOps people are very familiar with IRC or HipChat or a couple other chat tools before that. Slack has been revolutionary in the fact that not only can you communicate with your coworkers effectively and do video calls, but there are a lot of really great third-party integrations that can really help you with maintain operational and developer momentum. So when you create a Slack app, you can do things programmatically from within Slack externally. So first, we set up a Slack app, like in the screenshot that's up on the screen now. It doesn't have to be Slack. I'm just using this as a reference point for what we use at Mailchimp. HipChat does this. You can actually do this in IRC. There's a bunch of different ways that you can handle applications. But the core tenet is still the same. You're setting up a way for your chat application to talk to your infrastructure. So the next thing you do is you set up an API key with the Akamai IAM rule set. So being able to do identity management for this key allows you to recognize where your chat application is talking to Akamai. This is really helpful. So next, you can look at all of the EdgeGrid API examples. EdgeGrid is the way that you can talk to Akamai's infrastructure. They have libraries for pretty much every major programming language. If you can't find the one that you want, there's also an EdgeGrid curl library, so you can integrate it in any way that curl is integrated into your whatever language of your choices. And I'm sure that the Akamai developer team would love pull requests for this if there's a specific language that's not available. So after we use all those, let's talk about an example app that we have. blocking bad IP addresses. Who recognizes this IP address space? It's AWS. Whenever I see this, this is how I feel. A lot of the time, we get malicious acting traffic coming from AWS. A lot of developers and operators have seen this before. This is not a new surprise. What is a surprise is to see that there's 1,527 different IP address ranges that just Amazon produces alone. That's not true with GCP or Azure or some of the other cloud providers. So this list gets very untenable very quickly. And a lot of the time, your developers will start working on something, they'll develop a new product or feature, and then they see something funky. They see a huge uptick in traffic for a particular endpoint or a particular request or whatever, and they feel like this is happening to them. They feel like they're getting hacked in process. So what do you do about this? Just let the guy at Best Buy touch all the laptops? No, that's not what you do. So we can use chatops to help solve this problem. So this is an example chatop that I've come up with. So in this example, I say @bot block 1.2.3.4. He's being a jerk. So you can tie your bot into your Akamai logic and then into your management software to be able to block end users that are acting maliciously. This is really nice. So as we're doing this, this has been really helpful for our developers to gain momentum. We have developers that are on call all the time. And as we are mitigating problems, we can use Slack to mitigate these issues. Previously, our end users would have, if they were on call and they got paged because we were having an incident, they would have to go out, like let's just say they were at dinner. They would have to go out to their car, grab their laptop, find a Wi-Fi hotspot or connect to their phone, log into your VPN, get onto the Akamai portal, try and remember your password, go into the Akamai portal and see if this IP address space is blocked already or not. If it isn't, you have to push it out to staging, vet that it's working as expected, push it to production, vet that it's working as expected, check on it later. Don't have to do that anymore. If you tie all these things into your chat management software, you can just say @bot block this bad IP address and go on with your dinner. This is really nice. It's helped a lot with our internal teams. So the next thing we're going to talk about is enabling our customer support teams with Akamai APIs. Womp womp. Who's seen one of these before? I have. When you make a request that's malformed, blocked, or otherwise stopped at Akamai, oftentimes they'll send you back a reference error like the one on the screen. This is great. It helps you to realize that there's a problem and that you need to mitigate it somehow. But this isn't really readable. Sometimes you can sort of guess by the first number what kind of request it is based on previous experience, but it's not always clear to us what the problem is. So Akamai gives us this really great debugging tool. So you throw in that error string into this block in the Akamai portal, wait a minute or so, and it'll spit back all sorts of really valuable information about that particular request. This is nice. But as I mentioned earlier, not all of our developers, not all of our operators, and not all of our support people have access to the Akamai portal. So they feel like they're swimming in the dark. They don't really know what the problem is, and then they have to escalate to an operations or development person. This is OK, and we like to work as a team at Mailchimp to achieve common goals. But wouldn't it be nice if we could just enable our customer support people and our developers to be able to solve this problem on their own, or minimize the number of times that they have to talk to our operations and development teams? I think that sounds like a pretty good use of our time. So being able to do this, we have an internal portal that has all sorts of different tools that help our customer support agents succeed. Akamai is integrated into this portal as well. As you can see, all of the different tools that are available in the diagnostic tools API, in the diagnostic tools portion of the Akamai portal, are also available via API. So if you write a wrapper around this, you can have your developers, your customer support people, your non-technical people, whoever, look at those error translator messages and come up with some really great insight into what's happening before they have to escalate it to a team that is probably working on something else. You can also use all these other cool tools, like the IP geolocator is really nice to be able to know where your end users are sitting. You can verify a CDN IP address to make sure that that is actually an Akamai IP address that's causing the stop. You can use all the dig and traceroute and all the other tools that Akamai provides to us free with one small API call and a little bit of HTML wrapping. This is really helpful for us, and I hope that it's helpful for you too. So the next thing that we want to talk about is arming developers with information. So when we go to the Akamai API portal now, we see this. It's a lot of APIs, huh? They have a lot of really great insight. And Akamai has a lot of very feature-filled, robust APIs that we can use in order to be able to do things programmatically rather than manually. Anytime we do something programmatically rather than manually, we reduce toil. Reducing toil helps our developers, our operations teams, and other teams keep forward with business momentum and not have to worry about doing things over and over and over again. So when we're doing this, creating these or using these APIs follows a very specific pattern. We create an API client. We acquire credentials from the API client with IAM. We instrument them with the Akamai CLI or the Edge Grid clients. Then we tie in the usage of the API to the problem space that we're trying to solve for. And then we add monitoring and alerting around these tool sets. So if we see a lot of error translator issues coming up in our internal portal, then we know that something's probably going on in a larger sense. And we probably want to talk to our customer support team or other people that may be involved in these instances. This is really nice. Being able to be armed with these bits of information using APIs is really helpful. So today, we've talked about 3 separate things. We've talked about Akamai configuration best practices using cookie cutter templates. We've talked about how to balance cacheability with a developer focus using Webpack, Varnish, and other tools. And we've talked about using chatops with Akamai APIs. Thank you. A couple other notes. My slides are linked at the bottom here, so if you want to be able to check them out, that's great. Please make sure that you rate this session in the app if you had a good time. If you didn't, I'm going to be answering questions now if anybody has them. Wait for the microphone, please.
Hi. Could you explain what you meant about Varnish? I could not understand. It's an additional caching at the origin. What is the benefit of having that?
Sure. Let me go back to it. There you are. So the rightmost computer in this diagram is the origin, and then the black server is the Akamai network. If you add a caching layer in between those, Varnish is a good example of this. There are others like Squid, and there are a bunch of proprietary solutions too. Adding that layer of cacheability is nice for 2 reasons. One, it puts less strain on your origin when Akamai has to make requests. Those requests can be served directly from Varnish. 2, you can configure those servers to set the caching rules upstream at Akamai so that you don't have to log into the portal and change caching settings. You can actually just set them at Varnish with an edge control header. And it allows you to keep the Varnish configuration as code. And as we see more and more often now, we're putting more configurations as code rather than having them be very specific for hosts. And being able to do this allows others to have more visibility into your caching rules rather than having to go to the Akamai portal.
Okay.
So I have a question about the caching. Do you have any Google extension that helps with identifying what the headers are for caching? I've used the one that is for debug, which gives you a raw version of all the header, but something more sophisticated that, for instance, showing me like what the TTL is, the stuff that you talked about. There is an extension or even a mobile app for it?
Sure, that's a very good question. I'm going to repeat it. So he was asking about what is the right way to be able to get more visibility into the Xcache key and other headers that are coming back from Akamai. So having worked at Akamai and worked at Mailchimp doing Akamai work, I've had to deal with this a lot. And I find it to be sort of frustrating sometimes. But the best solution that I found is there is a Chrome and Firefox extension called mod header. And this has been helpful for me not just in this context, but in others. You can add any kind of request header that you want as it's going out into the, as your request is going out to the public internet. Then it'll show you the appropriate response headers. So if you add the Akamai Pragma header to your request, it'll actually show all of these in your web browser on the response. There's a really, really great article about the Akamai Pragma header in the Akamai community within the Akamai portal. So if you want to be able to evangelize that internally, or if you just want to read a little bit more about it, that's a great place to do it. And if you have other questions, I'm more than happy to answer them later on today, too.
I was just curious about the wildcard SANs that hadn't really heard of that option before. Is there any kind of limit within that? Like theoretically, that could be like the current limit on our CERT is like 99 SANs, right? So if we did a wildcard, how many actual domains could that cover?
So this is a question to best ask your Akamai representative because it's a sliding window. I know that you can have on the order of magnitude of tens of wildcards and tens of subject alternate names, but not both. So for us, what we do is a lot of our top-level domains, like Mailchimp.com, Mandrill.com, some of the other internal test domains we have, we'll add those as SAN names, and then we'll add star.admin.mailchimp.com, star.api.mailchimp.com, et cetera, et cetera. Yeah. And doing this has helped us minimize from tens of SSL certificates to manage to one.
Okay, thank you.
No further questions? All right, thank you for your time today.